Example 12.5, we're given an expression for the particle's velocity v, and v is equal to 6t minus 3t squared units meters per second. I'll call this equation number 1. And we know that at some initial time, which I'll designate by t0 equals 0, the position of the particle is equal to 0. We're told that the final time, if I call tf, is equal to 3 seconds. We want to find a few properties. The very first one is to find a final, that is a at time t equals 3 seconds. We are also asked to find the position of the particle at this final time. We need the total distance that the particle has traveled during this 3-second interval, and we also want a fourth component, which is the average speed. So we want v average. So the method, since we have several things to calculate here, we want to make sure that we understand which equations we'll be using. Specifically, v is a function of time, and for part 1, to find acceleration, everybody remembers the expression a is equal to dv dt. And so, using equation number 1, we differentiate that expression with respect to time, and we get 6 minus 6t. And of course, this is an expression for acceleration. The unit will be meters per second squared. Now, at time t equals 3 seconds, therefore we can find a final, and a final will be 6 minus 6 times 3. Of course, I'm just using equations 2 and 3 here, substituting the information for time 3, and this turns out to be minus 12 meters per second squared. You note that this final acceleration is a negative quantity, and therefore it is a deceleration. So that final acceleration is a negative value. That's what they're talking about when they said it is a deceleration. I'll call this equation number 4. Now let's go to the second part. The second part wants, we want s when the time is 3 seconds. And if you remember the expression, v is ds dt, this means I can now write the expression. If I rearrange the variables, I can write the s. I integrate. Please make sure you put in the limits of integration here. Must be the integral of v dt. Since time is what is changing here, my limits will be t0 to any t. So I can find the expression for s at any time. So if I integrate the left-hand side, this says that s is equal to the integral of, now let's just bring in the expression for velocity from equation number 1, 6t minus 3t squared dt, and I'm going to integrate this, of course, from t0, which of course we know is 0, to any time. And this gives us that s is equal to, and the expression now becomes 3t squared minus t cubed. So equation number 5 is an expression for position. You note here, how did I get equation number 5? If I go to the preceding equation here, and you will note that I have integrated this term. When I integrate 60, I get 6t squared over 2, and that is what resulted in the value 3t squared. When I integrate 3t squared, I get t cubed. So using that expression for s, we will now be able to write the value, or to obtain the value. Therefore, s at that final time, remember what we want, s final when t is equal to 3 seconds, turns out to be 3 times 9 minus t cubed, which is again 3 cubed, or 27 minus 20. So we have 3 cubed here, which is equal to 0. So my next answer here is f final is equal to 0. Let's continue and find the total distance traveled. Now, to get the total distance traveled, we first check to see if there is a change in direction during this 3-second interval. In order to do this, we will set v equal 0. And when we set v equals 0, from equation number 1, it implies that, and if I just factor out the t into 6 minus 3t must equal 0. And the solution for this, it implies that t is equal to 0 or 2 seconds. I'll call this equation number 7. Therefore, since the motion starts at time t equals 0, there's going to be a change in direction when time t equals 2 seconds. And so, remember the expression we discussed in class, the s total, that is the total distance traveled, becomes the absolute value starting from when the motion begins, s0, minus s at 2 seconds, plus s at 2 seconds, and the motion we knew ended at 3 seconds, or s final. And this turns out to be s at 0, if you remember, is 0. Now s at 2, we go to the expression for s, which of course we know is 3t squared minus t cubed, or 3 times 4 minus 2 cubed, which turns out to be 4 meters. So we have a minus 4 plus s at 2, again, which is 4. S final from equation number 6 is 0. Let me just reiterate here. How did I get S2? S2 is, I'm going to go to that expression for S. It will be 3 times 2 squared minus 2 cubed. And if you evaluate this expression, you'll find that this turns out to be 4. Finally, we see that S total, therefore we see that S total is equal to, and we have 8 meters. And finally, we want the average speed. So V average by using the equation, of course, S total over delta t, which your delta t is going to be your t final minus t initial, and this turns out to be 8 meters, and the total time was 3 seconds, and this of course is 2.67 meters per second. So please be careful. Again, students usually ask about this total distance traveled. I'm using the absolute value. So the absolute value of 0 minus 4 is minus 4, and the absolute value of minus 4, sorry, is 4. Similarly, absolute value of 4 is 4. So you have a 4 and a 4, which is 8. If you are asked to get V average, do not forget that you're dealing with total distance divided by total time. Okay, if you have any questions, as usual, if anything is not clear, please feel free to ask questions in the next lecture or the next class.